Okay, so video 2 for our resources and energy unit is going to be we're going to continue with the non-renewable resources, but I want to focus on mining and how the recovery of non-renewable resources happens. So we classify non-renewables into like 4 different categories. Either they have been identified, which is we know where they are, we know how much there is, we know what kind of quality it is, based on evidence, measurements that have been taken. They can be undiscovered, so they're potential supplies. We assume that they are there, but we don't know for sure. A reserve is an identified resource that we can extract. And then other is undiscovered or unidentified resources not classified at this point. Okay, so the direct benefits to mining resources, the money is received for resources, it's jobs, huge money income. The indirect is reclamation of land brought back to the original condition and sold for profit, so to be used after the mining has been completed. Okay, so the effects, environmental effects of using those resources. You have to look at it, the extraction as one, what happens when you actually mine the stuff, what happens when you process the stuff, and then what happens when you use the stuff. So I've talked about the use of stuff already, that was in our last notes, and I'm going to focus on the extraction, which is the actually mining, and then the processing, which is the separation, the smelting, the melting, all that kind of stuff. Okay, so the tons of methods you can use for how to remove minerals from depth, or how to remove minerals from the area based on depth. But the 2 basic methods are the surface or subsurface. Really clear. Surface is at the surface, you're digging up and you're taking out shallow deposits. Subsurface is you have to dig deep to remove the resources. Okay, so surface mining. Open pit mining is one of them. You dig a hole, you remove everything, and then you sort it out. One of the negatives, the big negative to open pit mining, is that you get this toxic, because all the chemicals you're using to sort it, to pull it out, you get this toxic groundwater at the bottom of your pit. Strip mining, you remove away, so the overburden is the soil, the trees, the plants, so whatever's on top of it. So area strip mining is you remove a strip of the overburden, you remove the mineral deposit, and then if you have to reclaim, then you'd have to put that overburden back. If you don't, then they just leave it, and so that leaves huge amounts of erodible areas. They're called spoil banks, where all of this stuff, there's nothing there, right? There's no soil anymore, there's no trees anymore, so that causes huge amounts of erosion. Contour strip mining is used on non-flat surfaces, so like in hills or mountainous terrain. And again, if you don't restore that area, you have huge amounts of erosion, and this is called your high wall right here. So all of that, if you don't restore and build this back up, then all of this is going to erode over time and dig out at whatever was behind it that hadn't previously hypothetically been messed with. Okay, so the mountaintop removal is literally cutting off the tops, machinery, removing the tops of mountains to expose the coal. You dump all that waste into the streams and the valleys below, so hopefully what you guys are noticing with all of this types of mining is that your waste, your reclamation, whatever that's left, overburden, is getting dumped somewhere or back on top of whatever it is. Is it ever going to be the same? And then all of this wastewater stuff all of this waste is getting dumped and eroded into the fresh water below it. So you have huge amounts of water pollution. Okay, so now we go into subsurface mining. So if you're looking at underground mining, you have to dig some kind of shaft to the resource using machinery and or people to remove the resource and then bring it back to the surface. So this is much more expensive, much more time consuming, and much more dangerous. And this is a really good diagram that kind of shows you the different types. Okay, so after you mine the ore, you have to process the ore. And so processing is taking it, so the ore is all of the stuff that you have that has the good stuff like the coal that you want, plus all the rock and the whatever else that's in there. So you have to process it and remove the good stuff and get rid of the stuff that is not profitable to you. So that's called smelting, which means that they're treated with chemicals to extract the desired material. So the technologies, there's all different levels of ores, right? And each level is at a different price. So depending on what you want, if you use, you've heard about it, if you use a low-grade ore versus a high-grade ore, you can use that for different processes with different costs. So new technologies can increase the mining at affordable prices, but you still have those big environmental effects. And we're going to do some labs on that so you guys can see that. Most of the resources we have on land we can remove and we can use, although some of them, especially the subsurface, gets more and more expensive. But the stuff that's in the ocean, on the deep ocean floor, for the most part is too expensive for us to remove and use, and there's a lot of controversy over who owns what. Okay, so getting minerals from the oceans, like I mentioned in the last slide, the black smoke, or the last video notes, the black smokers or the hydrothermal vents, using those mineral-rich water is something that's up and coming. We're developing new types of materials instead of using the metals. We're recycling a lot more. Saves money, has a lower environmental impact. Nothing there is new to you. Reclamation is returning the overburden to a mine. So returning that surface soil, the leaves, the blah, 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 whatever, and making the land useful again. So the U.S. Surface Mining Control and Reclamation Act was put in place in 1977. It's associated with surface mining, and it requires whoever's doing the mining to make that reclamation, to return the land back to a useful state. So it's not necessarily back to the way it was. Reclamation is just back to something that can be used. Okay, so the non-renewable resources, we've talked about coal already. The quality depends on how it was metamorphosed, what type of coal it is. We use the coal for electricity, for heat, for steel, exports, industry. I talked about the 4 types of coal already. So we have most of the coal, right? You guys know that from the last slide. Nothing new there. Okay, so looking in a little more detail about the different types of coal, and again, I'll show you these samples. Peat is like that step before the coal. It's partially decayed, low heat content, but you can burn it. Remember, in places like Ireland and Scotland, they have been burning peat as a fuel for hundreds of years, and still do in some places. And then, because there's no trees, right? So they use that in the place of wood. Lignite is the brown coal, very low heat, low sulfur, limited supplies. Bituminous coal is a soft coal. This is what's used primarily as a fuel with a high heat content, large supplies, but it has a lot of sulfur in it. And then the anthracite is the hardest, has the most heat, the most carbon, and the least amount of water, so this is the highest quality fuel. Okay. Limestone is also, so remember, we're not just mining coal, we're mining all kinds of minerals, all kinds of metals, all kinds of stuff. And so this mining refers to all kinds of non-renewable resources, not just coal and fuel resources, if that makes sense. Just like when we talk about renewable resources, we can also talk about grasslands and forests as renewable resources. So, other stuff that we use and that we mine for is limestone. Limestone is very abundant in Texas. It's used in sidewalks and fertilizers, plastics, carpets, very common. Lead is used in batteries and in cars. Clay is used in books, magazines, bricks, and linoleum. And then gold, we all know that that's a very valuable resource, used as money for jewelry, used in medicine and electronics. The same for silver and some other precious metals. Oops, sorry. Okay, should I go back? Hang on. Okay. So, resources specific to Texas. Central Texas has the limestone, has tin, clay, lead, garnets, pearls, amethyst, and calcium carbonate. West Texas has talc, mercury, silver, petroleum, and sulfur. East Texas, over by us, has the lignite, coal, and petroleum. South Texas, lignite, coal, petroleum, uranium, and limestone. And then North Texas, the helium, uranium, petroleum, and the bituminous coal. In the U.S., central U.S. is the diamonds in Arkansas and the bituminous coal. West is gold, silver, copper. Remember, that's out by California. In the east is primarily coal. Think about like West Virginia, right? That's what I want you picturing. South is some gold in South Carolina, but primarily the coal. And then again, the north the same.